Hello everyone. In the beginning of the class, let us see new announcements. Okay, the first new announcement is March 29th, 2022 videos uploaded. Hello everyone. I have uploaded today's class videos to YouTube. The lengths and URLs of the videos are: Part 1, length 25 minutes 9 seconds. URL is this. Part 2, length 25 minutes 20 seconds. URL is this. Part 3, length 25 minutes 9 seconds. URL is this. Best regards, Wei Zhen Liu. Okay, the next new announcement is the slides of chapter 2 has been updated. Version 2022-0331. Hello everyone. I have uploaded the newest version of slides of chapter 2 to eCourse2 website. The location and the file name are eCourse2 website, wireless communications and machine learning. Course content, slides, chapter 2, reinforcement, learning for resource allocation in cognitive radio networks, slides 2022-0331.pdf. Compared with the previous version, the updates in this version include: 1. Page 9 underline compromises. 2. Page 9 underline baseband radio processor. 3. Page 11 underline distributed resource allocation. 4. Page 12 underline fitness. 5. Page 14 underline Q-learning. 6. Page 15 underline deep Q-learning. Best regards, Wei Zhen Liu. Okay, and the next new announcement is the handout of chapter 2 has been updated. Version 2022-0331. Hello everyone. I have uploaded the newest version of handout of chapter 2 to eCourse2 website. The location and the file name are eCourse2 website, wireless communications and machine learning. Course content, handouts, chapter 2 reinforcement, learning for resource allocation in cognitive radio networks, handout 2022-0331.pdf. Compared with the previous version, the updates in this version include: 1. Page 7 modify the solution to problem 1. 2. Page 7 add problem 2 and its solution. 3. Page 9 add problem 1 and its solution. 4. Page 9 modify the solution to problem 2. 5. Page 9 modify problem 4. 6. Page 9 add problems 6 to 9 and their solutions. 7. Page 10 modify the solution to problem 1. 8. Page 11 modify the solutions to problems 1 and 3. 9. Page 11 add problem 2 and its solution. 10. Page 12. Modify the solutions to problems 1 and 2. 11. Page 12. Add problem 3 and its solution. 12. Page 14. Add problem 2 and its solution. 13. Page 15. Add problems 1 and 2 and their solutions. Best regards, Wei Zhen Liu. Okay. Next, let us see the progress of the last course. Okay. In the last course, we have taught to chapter 2 slides, page 7, stimuli. Okay, let us continue the progress. Okay, please open the slides of chapter 2 and turn to page 7. Okay. Okay, when operating based on the cognition cycle, a CR, that is a cognitive radio, interacts with the wireless network environment by following a cyclical sequence of states, starting with the measurement of variables from the environment, seen as stimuli. Okay. What is stimuli? Okay, please see the handout. Okay, page 7, problem 1. What is stimuli? Solution, plural of stimulus, specialized. Problem 2. What is stimulus? Okay, solution, something that causes growth or activity. Okay, back to the slides. In the observed state, okay, please go back to figure 2.1. We can see that here is the observed state. Okay, from which the CR interprets the state of the environment. The result of the observed state is fed to the decide state. Okay, let us go back to figure 2.1 again. Okay, observed state then fed to decide state. Okay, where the CR uses the current state of the environment and information learned from past experiences to adaptively decide on actions to be used to communicate through a radio waveform. The chosen actions are translated into parameter settings and applied to the transmission of a message in the last state of the cognition cycle, the act state. Okay, let us go back to figure 2.1. Okay, after the decide state, we will go to the act state. Okay, like this. The complete cognition cycle starts with the CR measuring variables from the environment and ends with the CR interacting with the environment by realizing the chosen actions, effectively having the environment as the medium through which the cycle is closed. At a deeper level, the use of the CR paradigm with its cognition cycle presents opportunities for more effective resource allocation solutions beyond what is apparent from the direct application of ML. Okay, here ML means machine learning algorithms. Okay, a case to this point is the realization of cross-layer techniques for resource allocation. It is well known that a cross-layer approach to resource allocation leads to better performing solutions. However, commercial wireless device architectures remain layered, not only because a cross-layer design may lead to compromises. Okay, what is compromises? Please see the handout. Okay, page 9, problem 1. What is compromises? Solution: an agreement in an argument in which the people involved reduce their demands or change their opinion in order to agree. Okay, let us go back to the slides. On a modular, okay, what is modular? Let us see the handout. Okay, problem 2. What is modular? Solution: consisting of separate parts that, when combined, form a complete whole. Okay, let us go back to the slides. On a modular network protocol implementation, but more importantly, because the development process over the complete networking stack. Okay, what is the networking stack? Okay, please see the handout. Okay, problem 3. What is networking stack? Solution: the protocol stack or network stack is an implementation of a computer networking protocol suite or protocol family. Please see figure 2. Okay, figure 2 is the protocol stack of the OSI model. I will explain what is the OSI model later. Okay, in the OSI model, there are 7 layers. Okay, like this. Okay, the layers 1, 2, 3 are called media layers, and layers 4, 5, 6, and 7 are called host layers. Okay, in layer 1, the data unit are bits, and this layer is called, okay, this is layer, these are layers. Okay, and this layer is called the physical layer. The physical layer is responsible for media, signal, and binary transmission. And in layer 2, the data units are frames. And this layer is called the data link layer, okay, which is responsible for physical addressing, MAC and LLC. Okay, we have explained what is MAC in chapter 1. If you forget it, please review the handout of chapter 1. And I will explain what is LLC later. Okay, in layer 3, the data units are packets, and this layer is called the network layer, which is responsible for path determination and logical addressing, IP Okay, I will explain what is IP later. In layer 4, the data units are segments, and this layer is called the transport layer, which is responsible for end-to-end connections and reliability. In layer 5, the data units is data, and this layer is called the session layer, which is responsible for inter-host communication. In layer 6, the data unit is data, okay, also data, and this layer is called the presentation layer, which is responsible for data representation and encryption. In layer 7, the data unit is data, and this layer is called the application layer, which is responsible for the network process to application. Okay, this is the protocol stack of the OSI model. Okay, then problem 4. What is the OSI model? Solution. The Open Systems Interconnection Model, OSI model, is a conceptual model that characterizes and standardizes the communication functions of a telecommunication or computing system without regard to its underlying internal structure and technology. Okay. And problem 5. What is LLC? Solution. In the IEEE 802 reference model of computer networking, the logical link control LLC data communication protocol layer is the upper sublayer of the data link layer, layer 2 of the 7-layer OSI model. Okay, problem 6. What is IP? Solution. The Internet Protocol, IP, is the network layer communications protocol in the Internet Protocol suite for relaying datagrams across network boundaries. Okay, problem 7. What is a datagram? Solution. A datagram is a basic transfer unit associated with a packet switched network. Okay, problem 8. What is a packet switched network? Solution. In telecommunications, packet switching is a method of grouping data into packets that are transmitted over a digital network. Okay, so let us go back to the slides. So the complete networking stack is divided into different teams, each specialized in implementing one layer or a sublayer in a specific processor, for example, main CPU or baseband radio processor. Okay, what is the baseband radio processor? Okay, let us see the handout. Okay, problem 9. What is a baseband radio processor? Solution. A baseband processor, also known as baseband radio processor, BP or BBP, is a device, a chip or part of a chip, in a network interface controller that manages all the radio functions, that is, all functions that require an antenna. However, this term is generally not used in reference to Wi-Fi and Bluetooth radios. Please see Figure 3. Okay. Figure 3 is the baseband processor SITEL SC14434. Okay. You can see that it is a chip, or you can say it is an IC. Okay, let us go back to the slides. Okay, next page. This results in software modules that lack the capability to exchange the data and commands needed to implement cross-layer solutions. Nevertheless, okay, what is nevertheless? Okay, let us see the handout. Okay, page 10, problem 1. What is nevertheless? Solution: despite what has just been said or referred to. Okay, let us go back to the slides. Nevertheless, as illustrated on the right part in figure 2.1. Okay, let us go to figure 2.1. The right part. We can see that there are 5 layers here, layer 1 to layer 5, and the layer 2 output is go to the observed state, and the observed state is fed to the decide state, and after the decision we will go to the act state. And the output of the act state is input to layer 2 again. Okay. Oh, sorry. The layer 1 to layer 5, they have 5 outputs, are all input to the observed state. And the output of the act state is input into all the layers, that is layer 1 to layer 5. So this is the cognitive engine, and we call this cycle as the cognition cycle. Okay, let us go back to page 10. The cognition cycle enables seamless modular cross-layer wireless networking technology by implementing a cognitive engine that senses the environment in the observed state. Okay, so senses the environment is means to observe the environment, and issues actions on the environment in the act state. Okay, so in the act state, we choose what action we should take with variables and parameters that correspond to all layers, that is layer 1 to layer 5 of the networking protocol stack. Okay, this is a framework that gracefully. Okay, what is gracefully? Let us see the handout. Okay, page 11. Okay, it is 25 minutes. Let us take a break.